Assalamualaikum warahmatullahi wabarakatuh. My name is Zamarul Aidil bin Muhammad Zamri. My registration number is 2024288112. So I will start with the introduction of building management and maintenance. Building management and maintenance in Malaysia has enveloped alongside the country's rapid urbanization and economic growth. Initial focus on basic maintenance activity, the increasing development of high-rise building, shopping complex and gated community creates a need for more structured property management system. The establishment of Board of Valuer, Appraiser, Estate Management and Property Management under Act 242 has helped regulated and professionalize property management practice in Malaysia. Building maintenance and management involves maintaining, repairing and improve buildings to ensure safety, comfort and functionality. It covers not only physical maintenance but also facilities management, security, cleanliness and resident services. Tenant satisfaction depends on effective maintenance, clean commons area, reliable utilities, strong security system, and clear communication. Furthermore, the growth of Malaysia real estate sector and the increase of adoption of green building practice have highlighted the importance of efficient, sustainable, and well-organized building management. Next, I will explain the scope of study. This assignment involves acting as a professional building management and maintenance firm appointed to manage and maintain Pang Sapuri Damai Shah Alam. The firm is responsible for ensuring efficient building operation, including the maintenance of building component, facilities, technical system, and support services, while incorporating green building principles that promote sustainability and energy efficiency. The study aimed to evaluate the effectiveness of building management and maintenance practice in ensuring operational efficiency, occupant comfort, safety, and overall building performance. Pang Sapuri Damai 25 was selected as the case study due to its mixed development nature, comprising of 682 residential units and 11 commercial units. As a stratified development with a large number of occupants, effective management and maintenance are essential to ensure the building safety, functionality, sustainability, and long-term value. Next, I will explain the objective of study. First, to identify the management and maintenance system implemented at Pang Sapuri Damai 25. Second, to review the level of effectiveness of facilities management, technical system and building service to ensure the comfort and safety of occupants. Third, to evaluate the implementation of green building elements such as energy efficiency, cleanliness and sustainability aspect in building operation. And lastly, to propose improvement to building management and maintenance to be more systematic and effectiveness. Now I will explain the scope of study. This study focused on the building management and maintenance practice at Pang Sapuri Damai Section 25. It examines the organization structure, building ownership, and the management role in ensuring efficient daily operation and long-term building performance. The study covers key aspects such as facilities and maintenance management, security, cleanliness, utility management, financial management, occupant relation, and compliance with safety regulations. Sustainability initiatives, including energy conservation and waste management, are also considered. However, the study focuses solely on operational and maintenance aspects and does not cover property marketing or sale activity.
Assalamualaikum. My name is Adlina, and I will begin with introducing the Pansapuri Damai 25. This is a mixed development property consisting of both residential and commercial properties. The development contains approximately 682 residential units and 11 commercial units. At the time of our interview with the building executive, around 671 residential units were actively occupied. The development consists of 5 blocks, namely Blocks A, B, C, D, and E. Blocks A and B are 6-story buildings. Blocks C and E have 12 stories, while Block D is the tallest block with 13 stories. The project was completed in 2 phases, with Block A and B completed in 2013, followed by Block C, D, and E in 2015. The property is managed by a joint management body, or JMB, which oversees the maintenance, financial administrators, facility management, and overall building operations. Due to the large number of units and multiple blocks, systematic maintenance planning is essential to ensure smooth building operations. In the future, the implementation of a computerized maintenance management system, or CMMS, could further improve maintenance, monitoring, and record management. Next, I will discuss the location and surrounding environment of the development. Pansapuri Damai 25 is located at Jalan Tokoh 25/28, Section 25, Taman Seri Muda Shah Alam, Selangor. It is situated within the established residential area that is surrounded by various housing developments, commercial premises, and community facilities. The location benefits from good accessibility through major road networks connecting Shah Alam and nearby areas. Residential have convenient access to shops, restaurants, educational institutions, and other public amenities that support their daily needs. From a maintenance perspective, the urban location and high occupancy rate result in continuous usage of common facilities and services. This increases the wear and tear of building components such as lifts, corridors, staircase, parking facilities, and utility systems. Therefore, preventive maintenance and regular inspections are crucial to maintain a safe and comfortable living environment. Moving on to the building age and history, the construction of Pansapuri Damai 25 was carried out in 2 phases. Blocks A and B were completed in 2013, while Blocks C, D, and E were completed in 2015. This means the development has been in operation for approximately 11 to 13 years. As the building has aged, several maintenance issues have become more noticeable. According to the management team, recurring water leakage problem has been reported, particularly on the upper floors. Lift breakdowns are also among the most common maintenance issues to aging equipment and previous flood incidents. In addition, structural cracks and settlement-related issues require continuous monitoring. Despite these challenges, the management team continues to conduct regular inspection and maintenance work. As the building enters its second decade of operation, life cycle maintenance planning becomes increasingly important. Future initiatives such as lift modernization, waterproofing replacement, and structural condition monitoring should be considered to improve long-term building performance. Now, I will explain the building's function and occupancy. The primary function of Pansapuri Damai 25 is residential accommodation. Based on the information obtained during the interview, approximately 70% of the occupants are families, while the remaining 30% consists of individuals, occupants, and tenants. The high occupancy rate significantly influences maintenance requirements. Common facilities such as lifts, corridors, staircase, playground, and parking areas are frequently used on a daily basis. As a result, these facilities experience a gradual wear and deterioration over time. In addition, the development includes commercial units that support the needs of residents. This mixed-use characteristic increases the complexity of maintenance management because every users have different requirements and expectations. Therefore, maintenance planning should focus not only on the repairing defects but also on ensuring service quality, residents' comfort, and user satisfaction. Next, I will discuss the facilities and services provided within the development. Pansapuri Damai 25 offers a variety of facilities for residents, including lifts, a gymnasium, playground, multipurpose hall, surau, car wash area, and reading room and parking facilities. The parking arrangement differs according to the building blocks. For building A and B, parking spaces are located in the external parking areas surrounding the buildings. Meanwhile, for blocks C, D, and E, parking facilities are located on level 1 and 2, with residential units starting from level 3. To ensure smooth building operations, management services such as security, cleaning, maintenance, pest control, and complaint management are provided. Residents can submit complaints through various channels including management office, email, WhatsApp, and e-community applications. These multiple communication platforms can help improve response time and maintenance efficiency. Future improvement may include smart access control system, digital facility booking platforms, and enhanced monitoring technology to improve operational efficiency and user convenience. Finally, I will explain the key building system that support the daily operations of Pangsapuri Damai 25. The Pangsapuri Damai 25 relies on several important systems including the electrical system, water supply system, plumbing and sanitary system, lift system, and security system. The electrical system receives power from TNB and support lighting, lift operations, CCTV equipment, and common area installations. The water supply system uses a water riser arrangement that allows a technician to access distribution pipes more easily for maintenance purposes. The plumbing and sanitary system consists of water supply pipes, rainwater pipes, and sewage pipes. However, water leakage remains one of the most common maintenance issues, often caused by defective waterproofing, damaged pipe, or water penetration through building elements. The lift system plays a critical role in residential accessibility, but frequent breakdowns have been reported due to the aging equipment and previous flood incident. Therefore, lift modernization and predictive maintenance strategies should be considered in the future. Lastly, security system includes CCTV surveillance, RFID, access control, and security personnel to ensure resident safety. Future integration of cloud-based monitoring and smart surveillance technologies can further strengthen security and operational efficiency.
Hi, my name is Muhammad Firdaus bin Muhammad Azan. For this section, I will explain the building design and maintenance consideration of Pangsapuri Damai 25. Pangsapuri Damai 25 is a mixed development project that includes both residential and commercial components. The development consists of approximately 682 residential units and 11 commercial units distributed across 5 building blocks. Blocks A and B have 6 stories, while Blocks C and E have 12 stories. Block D is the tallest building with 13 stories. The development also provides several common facilities for residents such as passenger lifts, a gymnasium, a playground, a multi-purpose hall, and a prayer room. In, term, in terms of building design, Pangsapuri Damai 25 use a typical apartment layout commonly found in Malaysia residential developments. The main building materials include reinforced concrete structures, tile finishes, and steel components. The parking arrangement differs between the building blocks. Blocks A and B use external parking areas, meanwhile Blocks C, D, and E provide parking spaces on levels 1 and 2, while the residential units begin from level 3 onwards. From a maintenance perspective, one positive design feature is the water riser system. The system allows the water supply pipes to be accessed through dedicated service room. Therefore, inspection, repair, and maintenance work can be carried out more easily compared to conventional concealed piping system. However, the high-rise design and large number of common facilities also create several maintenance challenges. More facilities, building, building services, and common areas require regular inspection and continuous monitoring. This increases the complexity of maintenance, planning, and management. Therefore, future improvement should include the implementation of computerized maintenance management system or CMMS, as well as digital maintenance tracking platforms. This system can help the management teams schedule maintenance work, record complaints, monitor repairs, and track the condition of building facilities more effectively. Overall, the building has several positive design features, but the use of digital maintenance system is important to improve maintenance, planning, operational efficiency, and the long-term performance of Bangsa Puri Damai 25. For this section, I will explain the construction materials used in Bangsa Puri Damai 25 and their maintenance implications. Based on the interview and site inspection, the building was constructed using conventional materials commonly found in residential developments. The main material used are reinforced concrete, steel, and ceramic tiles. Reinforced concrete is the primary structural material because it provides high strength and durability. This makes it suitable for supporting a multi-story residential building. Ceramic tiles are widely used for floor and wall finishes because they are durable, easy to clean, and require relatively low maintenance. Steel is Steel is also used for several building components such as railings, support structures, and service installation. Although these materials are generally durable, several maintenance issues have developed over time. According to the building executive, recurring water leakage has occurred in several areas of the development. These leakage problems may be caused by the deterioration of waterproofing system, aging materials, and long-term exposure to weather and environmental conditions. In addition, visible structural cracks and settlement-related problems have been reported in certain parts of the building. These conditions should be monitored carefully because they may affect the long-term performance and safety of the structure. Therefore, periodic structural inspection and building condition assessment should be carried out. Crack monitoring system can also be installed to track changes in the size and condition of structural cracks. For future refurbishment works, the management should consider using advanced waterproofing materials, protective coatings, and higher durability construction materials. This improvement can help reduce recurring defects, lower maintenance frequency, and minimize the building's long-term life cycle costs. Overall, the existing construction materials provide adequate durability. However, regular monitoring and the use of improved materials are necessary to maintain the safety and long-term performance of Pangsapuri Damai 25. For this session, I will explain the maintenance accessibility at Pangsapuri Damai 25. Maintenance accessibility is an important factor because it affects repair costs, maintenance response time, and the amount of labor required. A building with good maintenance accessibility allows inspection and repair work to be completed more quickly and efficiently. One positive feature at Pangsapuri Damai 25 is the water riser system. The dedicated service room allow maintenance personnel to access the water supply pipes more easily. This reduces the need to damage wall or finish or other building finishes during inspection and repair work. However, several building components are still difficult to access. This include concealed pipe systems, box-up service areas, and rooftop facilities. In some cases, contractors need to remove part of the wall finishes or building element to reach damaged pipe. This increases repair costs, labor requirement, and maintenance duration. Recurring water leakage also makes maintenance work more complicated. Technicians may need to inspect several residential units before they can identify the actual source of the leakage. As a result, the investigation process becomes more time-consuming and costly. Therefore, future refurbishment work should be include accessible service panels, modular piping system, and designated maintenance access routes. This improvement will make building services easier to inspect and repair. Overall, improving maintenance accessibility would reduce maintenance complexity, lower repair costs, and improve the efficiency of maintenance operation at Bangsa Peridamai 25. For this section, I will explain the main maintenance issues related to the design and construction of Bangsa Peridamai 25. The most significant issues identified is recurring water leakage. Leakage has occurred in the residential units, common corridors, and building vacant areas. According to the management team, this problem is more common on the upper floors of several blocks. The main causes include waterproofing failure, deterioration of the building facade, piping defects, and structural movement. Building movement, uh, sorry, Building settlement has also caused cracks to appear in certain areas. This crack allow water to enter the building, resulting in repeated repair works and higher maintenance costs. Another major issues involve the lift system. Since Pasupuri Damai 25 consists of several high-rise blocks, lifts are essential for residents. However, aging lift equipment and previous flood damage have caused frequent lift breakdowns. When a lift fails, it affects resident accessibility, daily activities, and overall user satisfaction. Maintenance work is also made more difficult by concealed building services. Hidden pipes and service installation make it harder for technicians to identify the source of a problem. In some cases, walls or finishes must be removed to access and repair damaged components. To address this issue, the management should improve the waterproofing system, modernize the lift, and introduce the predictive maintenance. Smart monitoring technologies can also be used to detect leaks, lift faults, and structural movement at an early stage. Overall, this improvement will help reduce recurring maintenance problems, improve the building reliability, and provide a safer and more comfortable environment for residents. For this section, I will explain how the building design of Pangsapuri Dama 25 influences its maintenance requirement and operational costs. The design of the development has a direct impact on maintenance frequency and complexity. Since Pangsapuri Dama 25 consists of several high-rise blocks and many shared facilities, regular maintenance is required for lifts, lighting system, water tanks, plumbing system, generators, and security system. Recurring problems such as water leakage, structural cracks, and leaf breakdown also increase the maintenance workload. These issues require continuous inspection, monitoring, and repair to maintain the building's performance and ensure residents' comfort. According to the management team, daily inspections are often necessary, especially when responding to leakage complaints. Overall, the building design includes several functional features that support maintenance activities. However, aging components, limited accessibility, and recurring defects contribute to higher maintenance demand and operational costs. To improve long-term performance, the management should gradually apply design for maintainability or DFM principles during future upgrading and refurbishment works. This improvement may include accessible service panels, smart monitoring system, predictive maintenance technologies, and improved waterproofing system. In conclusion, applying this measure can help reduce maintenance costs, improve operational efficiency, and support the long-term sustainability of Pangsapuri Damai 25. For this section, I will present the proposed design improvement and maintenance consideration for Pangsapuri Damai 25. Based on the analysis, several design-related issues have contributed to recurring maintenance problems. These include water leakage, lift breakdowns, structural cracks, concealed service installation, and limited maintenance accessibility. The first and most critical issue is recurring water leakage, especially on the upper floors. To address these problems, the existing waterproofing system should be upgraded using high-performance waterproofing materials. IoT-based leak detection sensors should be also installed to detect water infiltration at an early stage. This will help prevent further damage to building components and reduce the cost of major repairs. The second area that requires improvement is the lift system. Due to aging lift equipment and previous flood damage, lift breakdowns occur relatively frequently. Therefore, lift modernization programs and predictive maintenance systems should be introduced. Smart lift monitoring system can continuously track lift performance and provide yearly warning alerts before serious failure occur. Next, structural cracks and settlement related issues should also be monitored continuously. Crack monitoring gauges and structural monitoring sensors can help the management team track structural movement and identify possible risks before they become more serious. Maintenance accessibility can also be improved by installing access panels for concealed pipes and service installation. This would allow maintenance personnel to reach damaged components more easily without unnecessarily removing or damaging nearby walls, ceilings, and finishes. In terms of energy management, the installation of smart energy monitoring system should also be considered. This system can monitor electricity consumption in real time and help management identify areas where energy is being wasted. This would reduce operational costs and support the building's long-term sustainability objective. Overall, this proposed improvement will enhance building maintainability, improve maintenance efficiency, and reduce operational disruption. They will also support the long-term sustainability of Bangsa Puri Damai 25 by promoting preventive maintenance, predictive maintenance, and the use of the smart technologies. Thank you.
Now I will explain the maintenance policy and organization structure. Building maintenance management is the systematic process of maintaining, preserving, and improving building facilities to ensure their safety, functionality, and efficiency. It's included activities such as routine inspection, preventive maintenance, and repair work for building system including HVAC, electrical, plumbing, and structural component. Modern technologies such as building management system (BMS) and LOT device are increasingly used to improve monitoring and maintenance efficiency. Effective building maintenance management helps to protect occupant safety, enhance operational performance, and extend the lifespan of building assets. A building maintenance policy provides clear guidelines and standards for managing maintenance activity, resources, and costs while reducing equipment failure and unplanned downtime. A well-implemented maintenance strategy contributes to better building performance, lower maintenance costs, and improved service quality. In maintenance policy, there is two types, which is preventive maintenance and corrective maintenance. First, preventive maintenance is a planned maintenance approach carried out regularly to reduce the risk of equipment and building system failure. It involves activities such as routine inspection, equipment testing, and scheduled servicing to detect and address potential issues before they become serious. This approach helps ensure smooth building operation, minimize disruption, and extend the lifespan of building assets. Next, corrective maintenance. Corrective maintenance refers to repair work performed after a fault or failure has been identified in a building system or equipment. It may be planned or unplanned depending on the severity of the issue. Common example includes repair to elevators, plumbing system, water pump, CCTV, and fire alarm. Although necessary, excessive reliance on corrective maintenance can lead to higher repair costs operational disruption, and reduce occupancy reliability compared to preventive maintenance. Now I will explain the roles and responsibilities of organization structure. An organization structure is a framework that defines the division of tasks, responsibility, authority, and relationship among individuals within an organization. It plays an important role in coordinating activities and ensuring that organizations' goals are achieved efficiently. A clear organization structure enables employees to understand their roles and responsibilities while supporting effective communication and decision-making processes. One of the key functions of an organization structure is to establish a clear chain of command. This allows employees to know who they report to, who is responsible for solving this issue, and how decisions are made. In building management and maintenance, a well-organized structure helps coordinate maintenance activity, allocate resources effectively, and ensure smooth daily operation. A properly structured maintenance team contributes to improve efficiency, accountability, and overall building performance. Now I will explain the roles and responsibilities of organization structure. An organization structure is a framework that defines the division of tasks, responsibility, authority, and relationship among individuals within an organization. It plays an important role in coordinating activities and ensuring that organizations' goals are achieved efficiently. A clear organization structure enables employees to understand their roles and responsibilities while supporting effective communication and decision-making processes. One of the key functions of an organization structure is to establish a clear chain of command. This allows employees to know who they report to, who is responsible for solving this issue, and how decisions are made. In building management and maintenance, a well-organized structure helps coordinate maintenance activity, allocate resources effectively, and ensure smooth daily operation. A properly structured maintenance team contributes to improve efficiency, accountability, and overall building performance. First, the building executive. The building executive is responsible for ensuring smooth and efficient building operations, including maintenance, security, vendor management, and staff supervision. The role ensures the building remains safe, clean, and comfortable while complying with maintenance standards. The executive also coordinates administrative staff, technicians, manage external contractor, and monitoring service performance. In addition, they act as the main liaison between resident management and the GMB by handling complaints and coordinating necessary actions. At Pansampuri Damai, the building executive oversees daily operation with support from staff, manage contractors such as security, cleaning services, handle issues like leak and lift breakdown, conduct regular inspection, and assist in planning future improvement to enhance building performance and resident comfort. Now I will explain the administrative team. The role of administrative team play an essential role in ensuring building operation runs smoothly and systematically. It's responsible for managing documentation, communication, financial records, and daily administrative tasks, making it the backbone of the building management system. Key responsibilities include receiving and recording occupant complaints, handling communication with residents, managing call correspondence, and coordinating maintenance requests. The team also support financial management by preparing invoices, recording expenses, and monitoring maintenance fee payment and arrears, which directly affect the building operational budget. At Pansapuri Damai 25, all complaints are received through the management office, email, e-community application, and WhatsApp. These are recorded and forwarded to the relevant technician or contractors for actions. The team also assists in coordinating maintenance schedule with external services providers such as lift maintenance, pest control, and water tank cleaning, while ensuring our records are properly documented for reference and reporting. Now I will explain the roles of building technician. Building technicians are responsible for inspecting, repairing, and maintaining systems such as electrical, plumbing, elevators, water tanks, lighting, and mechanical system. They are carry out routine inspection, performs minor repair, and ensure our facilities are safe and functioning properly. Technicians are also prepare maintenance report for management reference. Maintenance schedule are followed strictly, with daily check for water tanks and monthly servicing for elevators, generators, and pest control. For major issues that require external expertise, technicians report to the building executive to engage contractors. They also assist external vendors during repair works to ensure tasks are complete according to standards while helping to minimize maintenance costs and prevent further damage. At Pansapuri Damai 25, technicians conduct daily inspection focusing on common issues such as water leaks, which often result from piping problems, waterproofing defects, or structural cracks. They also perform regular check on lighting, electrical system, water tanks, elevators, generators, CCTV, RFID, and other utility systems to ensure proper functioning. Now I will explain the outsourcing versus in-house maintenance. Outsourcing maintenance refer to the use of external vendor or contractors to carry out the building maintenance tasks. This practice is common in property management as it provides access to specialized skills, technology, and services without requiring a large permanent workforce. It can also improve flexibility and operational efficiency. One of main advantage of outsourcing is cost saving as management does not need to pay salaries, training costs, or equipment expenses for in-house staff. However, its disadvantage includes limited control over work quality and performance, as well as contractors having less understanding of the building specific condition compared to internal staff. Therefore, outsourcing must be managed carefully to ensure service quality and effectiveness. Next, I will explain the in-house maintenance. In-house maintenance refers to maintenance work carried out by internal staff, giving management direct control over daily operations and activities. It allows faster response to complaint and breakdown because technicians are always available on site and familiar with the building conditions. However, it involves higher operation costs such as salaries, training, and employee benefits, and it may lack specialized expertise for complex maintenance work. At Pansapuri Damai, a small internal teams manage daily operation and minor repair, while major work are outsourced by creating a hybrid maintenance system. At Pansapuri Damai implement a hybrid maintenance management system which combine an in-house maintenance team with outsourced maintenance services. The internal team consists of building executive with 2 administrators and 2 technicians who are responsible for managing daily building operations, conducting routine inspection, monitoring facilities, and responding to resident complaints. Their preference on-site enable quicker response to minor maintenance issue and ensure that common facilities remain in good conditions. At the same time, more specialized and large-scale maintenance works are outsourced to external companies. Services such as security, cleaning, major pipes repair, structural repairs, and work requiring heavy machinery are handled by contractors with the necessary expertise and equipment. This approach allows the management to overcome manpower and technical limitation while ensuring maintenance work is carried out efficiently and professionally. So overall, the hybrid system helps balance operation costs, improve maintenance effectiveness, and maintain the safety and functionality of the buildings.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Raisa Kabir Rosli, and right now I'm going to continue this presentation by explaining to you about our inspection methodology. For this study, a qualitative case study approach was used to evaluate the maintenance management practices at Pasapuri Damai 35. Data were collected through 4 methods, which is site observation, photographic documentation, interview with the building executive, and review of maintenance records provided by the management office. The inspection cover major building components including the building facade, common area, lift system, parking facility, plumbing, and drainage system. Also, electrical system, fire protection system, and utility facilities. The information obtained was analyzed to identify building defects, evaluate the effectiveness of current maintenance practices, assess energy management performance, and develop suitable maintenance improvement strategy and smart technology recommendation. Okay, next is about key finding from interview session. The interview with the building executive provide us important insight into the current maintenance management practices and Pasapuri Damai. The building currently adopt a combination of preventive and corrective maintenance approach. Preventive maintenance include daily inspection, deep servicing, generator maintenance, pest control, and routine check on building facilities, while corrective maintenance is carried out when defects or breakdown occur. The interview identified water leak as the most common maintenance issue, mainly caused by waterproofing failure, plumbing defect, facade deterioration, and structural movement. Frequent lift breakdown were also reported due to aging equipment and previous flood-related damage. From an operational perspective, the management team consists of only 1 building executive, 2 administrative officers, and 2 building technicians, creating manpower challenges when handling increasing maintenance demand. Financial constraints caused by maintenance fee areas and approval procedure for major repair work were also highlighted as a key challenges. On a positive note, the management has already implemented several energy-saving initiatives, including LED lighting, motion sensor, timer control lighting, and RFID access system. However, the building has yet to adopt advanced smart technology such as IoT monitoring system, predictive maintenance tools, and integrate digital maintenance platform. This finding form the basis for the maintenance, improvement, and smart technology recommendation proposed in this study. Okay, next is about observed building defects. During the site inspection, defects were classified into structural, architecture, and building services defect. For structural defects, building settlements and structural cracking were identified as major concern. According to the building executive, certain sections of the building have experienced settlement which contribute to recurring crack and leakage problem. For architectural defect, water leakage was found to be the most common issue. Water staining, dam fault, and deteriorate finisher was observed in several common areas. These problems are mainly caused by waterproofing failure, packet deterioration, and plumbing-related defects. To address the issue, improvements such as crack monitoring system, structural assessment, waterproofing upgrade, and installation of maintenance access panel are recommended. Okay, next is about building services defect. For building services defect, the lift system was identified as the most problematic component within the development. Frequent lift breakdown occur due to aging equipment and previous flood-related damage. Since Pasar Damai is a high-rise development, lift reliability is essential for resident accessibility and comfort. Although the plumbing system generally performs satisfactorily, leakage issue and maintenance accessibility challenges still occur in several locations. In line with the study, focus on smart technology, several improvements are proposed including smart leak monitoring system, IoT leak detection sensor, smart energy monitoring system, and the implementation of computerized maintenance management system or CMMS. This technology would support predictive maintenance and allow defect to be detected before major failure occurs. Next is about evaluation of current maintenance practices. Based on interview findings, site inspection and maintenance record, the maintenance management system at Pasar Damai can be considered moderately effective. Several strengths were identified, including regular preventive maintenance activities, routine inspection, outsourced specialist services, and the ability of multiple complaint channels such as email, WhatsApp, the e-community application, and walk-in reporting. In addition, the management has already implemented several energy-saving measures such as LED lighting system, motion sensor, and timer control lighting. However, several weaknesses remain, like recurring water leakage issue, frequent leak breakdown, limited maintenance manpower, and financial constraints continue to affect maintenance performance. The findings also show that the current maintenance approach mainly focuses on preventive and corrective maintenance, with limited use of predictive maintenance technology. Therefore, it is recommended that the management gradually adopt smart maintenance solutions such as computerized maintenance management system, IoT-based monitoring technologies, digital inspection record, and predictive maintenance practices to improve operational efficiency and reduce recurring failure. Okay, next is about system inefficiency. Based on the maintenance audit, several system inefficiency were identified at Pasar Damai. The most significant issue is the frequent breakdown of the lift system with the aging equipment and previous flood-related damage. This failure affects resident convenience and increase maintenance costs. Another issue is poor maintenance accessibility. Many plumbing services are concealed within walls, requiring hacking works before repair can be carried out. This increase repair time, labor requirement, and maintenance expenditure. Recurring water leakage also remain as a major concern. The repeated occurrence of leakage suggests that temporary repair are often carried out without fully addressing the root cause of the problem. In addition, the maintenance team is relatively small compared to the size of the development, which affect maintenance response efficiency during period of high demand. To improve system performance, several solutions are proposed. These include installing IoT leak detection sensor, implementing smart leak monitoring system, introducing predictive maintenance practices, and improve maintenance accessibility through maintenance access planner. The summary of identified inefficiency and recommended improvement is presented in Table 544, which is the table of building system and plan improvement overview. Okay, next is about energy consumption and inefficiency. The audit also evaluate energy consumption and energy management practices at Pasar Damai. These findings show that several energy-saving initiatives was already been implemented, including LED lighting system, timer control lighting, motion sensor lighting, and EMS system. This measure had reduced electricity consumption and demonstrate the management commitment to energy efficiency. However, several energy inefficiencies still exist. Essential building systems such as lift, CCTV system, water pump, and corridor lighting operate continuously and contribute significantly to overall electricity consumption. In addition, the building currently does not have a centralized energy monitoring system to track energy usage in real time. The interview also revealed occasional billing issues caused by estimated electricity meter reading, making it difficult to accurately monitor energy costs. To improve energy performance, it is recommended that the management implement an energy management system integrate with IoT technology, smart electricity meter, and energy dashboard can provide real-time monitoring and help identify area of excessive energy consumption. In the long term, solar photovoltaic system can be considered to reduce dependence on grid electricity and support the building sustainability goal. The summary of identified energy efficiency and proper improvement strategy is presented in the table. Okay, lastly is about key issue that we identify. The final part of the maintenance audit summarizes the key issue affecting the overall performance of Pasapuri Damai. The most critical issue identified is recurring water leakage. The problem is mainly caused by waterproofing failure, plumbing defect, facade deterioration, and structural movement. This issue increase maintenance costs, require frequent repair works, and affect resident comfort. The second major issue is the aging lift system. Frequent lift breakdown reduce accessibility, inconvenience resident, and increase maintenance expenditure. Structural settlement and visible cracking were also identified as long-term concern. This defect require continuous monitoring and specialist assessment to prevent further deterioration and ensure building safety. Financial limitation caused by maintenance fee areas continue to affect maintenance planning and implementation. Budget constraints may delay repair works and limit the management ability to carry out major upgrading projects. In addition, manpower limitation and the absence of advanced smart maintenance technology reduce maintenance efficiency and affect long-term building performance. To address these challenges, several strategic solutions are proposed, including waterproofing upgrade, lift modernization program, predictive maintenance system, smart monitoring technologies, improved financial planning, and sustainable energy management practices. The summary of the key issue and corresponding solution is presenting in the table. Overall, although the current maintenance system is able to support daily building operation, several improvements are required to achieve a more proactive, efficient, and sustainable maintenance management system.
Based on the findings from the site inspection, interview sessions, and maintenance records, several recurring maintenance issues were identified upon Sapuri Dramai 25. These include water leakage, structural cracking, frequent lift breakdown, aging building services, limited manpower, and lack of advanced maintenance technologies. Those findings indicate that the current maintenance approach requires further improvement to ensure the building remains safe, efficient, and sustainable in the long term. Therefore, a comprehensive maintenance strategy is proposed to transform the current maintenance system from mainly preventive and corrective maintenance into a more proactive, predictive, and technology-driven approach. The proposed strategy includes strengthening preventive maintenance, implementing predictive maintenance technologies, introducing a computerized maintenance management system or CMMS, establishing a structural monitoring program, improving energy efficiency and sustainability, as well as strengthening workforce and contractor management. Overall, the strategy aims to reduce recurring defects, improve lift reliability, integrate smart technologies into maintenance operations, enhance energy efficiency, improve resident satisfaction, and increase the long term of the building. This table summarizes the overall proposed maintenance strategy. Firstly, for recurring water leakage, the proposed solution is to upgrade the waterproofing system and install IoT leak detection sensors. This will help reduce leakage cases and maintenance costs. Secondly, to address frequent lift breakdowns, smart lift monitoring and equipment upgrading are proposed to improve lift reliability and resident satisfaction. For structural cracking and settlement, a structural monitoring system with periodic assessment is recommended to enable early detection of structural issues. This current manual maintenance monitoring system will be replaced with a computerized maintenance management system or CMMS to improve maintenance planning and record management. To reduce high energy consumption, smart energy monitoring together with solar photovoltaic installation is proposed to lower long-term energy costs. The issue is limited manpower can be addressed by appointing additional technicians and energy management officers, allowing faster management response. Lastly, contractor dependency will be improved through a contractor performance evaluation system to ensure better service quality and accountability. Based on the inspection findings and maintenance audit, a comprehensive preventive maintenance schedule is proposed for Pangsa Peridamai 25. The main objectives are to reduce recurring defects, improve building reliability, minimizes the emergency repairs, and extend the service life of building assets. The maintenance program focuses particularly on building components that frequently experience problems, including leaf, system plumbing, waterproofing, components, and structural elements. In addition, smart technologies are incorporated into the maintenance program to support a more proactive maintenance approach through continuous monitoring and early detection of potential. This table presents the proposed routine preventive maintenance schedule for the building. Daily inspections include housekeeping of the common lobby, corridor cleanliness and lighting, water tank conditions, and lift operation checks to ensure smooth daily operations. Weekly inspections focus on leak inspections and monitoring the condition of plumbing system to prevent water leakage. Monthly maintenance includes lift services, drainage cleaning, waterproofing inspection, electrical panel inspections, fire protection system, CCTV testing, generator servicing, and pest control. Quarterly inspection involve monitoring structural cracks to identify any movement or deterioration. Semi-annual inspections are carried for the building facade to assess its overall condition. Annual maintenance include water tank cleaning, detailed structural inspection by professional engineers, and energy performance assessment to optimize building efficiency. These maintenance schedules ensures that every major building component is inspected according to the appropriate maintenance frequency. Moving on to the third image, which is the proposed annual maintenance calendar. This figure presents the proposed annual maintenance calendar for Pangsa Peridamai 25. Instead of carrying out maintenance only when problems occur, maintenance activities are planned throughout the year to ensure continuous building performance. For example, in January, structural inspections and crack monitorings are conducted to verify structural integrity. In February, water tank cleaning and plumbing inspections are carried out to ensure a hygienic water supply and prevent leakage. March focuses on leaf performance assessment to provide or to improve leaf reliability and minimizes breakdown. Fire protection systems are serviced in April to maintain safety compliance. Building facade inspections are scheduled in May to identify any signs of deterioration. June is allocated for reviewing the building's energy consumption and to improve operational efficiency. In the second half of the year, waterproofing inspections and repairs are performed in July, followed by generator servicing in August to ensure emergency power in readiness. Drainage inspections are conducted in September to prevent blockages and flooding. October focuses on CCTV and FRID systems to upgrades and to enhance the security. An annual energy audit is carried out in November to verify overall system efficiency, and finally December is used to review the overall maintenance performance, allowing management to evaluate the effectiveness of the maintenance program and plan improvement for the following years. Based on the inspection findings, several critical defects were identified at Pangsa Peridamai 25, including recurring water leakage, structural cracks, building settlement, and frequent leaf breakdown. Therefore, the proposed corrective maintenance program focuses on eliminating the root causes of this problem instead of continuously carrying out temporary repairs. The proposed improvement includes replacing defective waterproofing system, modernizing the aging lift systems, implementing structural health monitoring, installing smart leak detection sensors, replacing the aging plumbing system, rehabilitating the building facade, and introducing the QR code digital defect tamper reporting system. These measures are expected to improve building reliability, reduce long-term maintenance costs, and enhance resident satisfaction. On to the first image, these tables summarize the proposed corrective maintenance actions according to the identified defects. Water leakage is classified as a high priority issue. The proposed solution is to replace defective waterproofing system, repair damaged pipes, and install smart leak detection sensors. For structural cracks, professional structures assessments together with epoxy crack repair are proposed to restore structural integrity. Building settlement also requires high priority attention through geotechnical investigations and foundation strengthening works. Frequent lift breakdowns will be adverse by modernizing the lift system instead of repeatedly repairing the aging components. Medium priority works include facade waterproofing coating, complete repainting using weather-resistant paint, replacing the off-concealed piping with accessible maintenance panels, and upgrade the drainage system with monitoring sensors. Overall, these corrective actions aim to permanently solve recurring defects and improve long-term building performance. On the second image, in addition to physical repair work, several smart technologies are proposed to improve corrective maintenance efficiency. Firstly, IoT water leak sensors will continuously monitor leakage-prone areas and provide real-time alerts. Secondly, smart leaf monitoring system equipped with vibration and thermal sensors will enable predictive maintenance before breakdowns occurs. A digital defect reporting applications allows maintenance staff and residents to report issues instantly through mobile devices. Structural crack monitoring sensors continuously record crack movement, allowing engineers to monitor structural behavior more accurately. Finally, a computerized maintenance management system or CMMS centralized maintenance record schedule and work orders, improving maintenance planning and decision making. These technologies shift maintenance from reactive repairs toward predictive and data-driven maintenance. Now, moving on to the budget consideration. For this study, budget limitations were not considered. Instead, the proposed budget focuses on achieving the best long-term maintenance outcome and improving buildings. Investment is prioritized toward addressing critical building defects, improving maintenance efficiency, and integrating smart technologies. The total proposed maintenance budget is RM 2.83 million, with emphasis placed on long-term asset management rather than short-term repair. For the first image, this table shows the proposed maintenance budget allocation. The largest allocation is RM 800,000 for lift modernization due to the frequent lift breakdowns experienced by the building. RM 500,000 is allocated for waterproofing upgrades to permanently solve the recurring leakage issues. RM 400,000 is allocated to propose for the rooftop solar photovoltaic installations to improve long-term energy efficiency. Structural repair works received RM 300,000, while repainting works are allocated RM 250,000. Additional allocation includes smart leak detection system, CMMS implementation, smart energy monitoring, EV charging stations, and an emergency receive fund for unexpected repairs. These investments support a transformation of the Pangsapuri Damai 25 into a smart and sustainable residential development. Now, on to the second image. To strengthen financial sustainability, several revenue-generating initiatives are also proposed. Firstly, EV charging stations can generate additional management income while supporting future electric vehicle usage. Secondly, rooftop solar energy systems help reduce electricity bills through renewable energy generations. Digital advertisement panels can provide rental income from advertising companies. A smart visitor parking system allows visitor parking fees to be managed digitally, generating additional parking revenue. Lastly, leasing rooftop space for telecommunication equipment creates a stable, recurring income source for the building management. These initiatives reduce financial dependence on maintenance fees while supporting long-term operational sustainability. Moving on to the section 6.5, which focuses on the integration of energy efficiency measures at Pangsapuri Damai 25. Based on the site inspection and interview findings, the building has already implemented several basic energy saving initiatives, including LED lighting, timer control lighting systems, and the motion sensor lighting inside selected common areas. These measures have helped reduce electricity consumption compared to conventional building operations. However, the building energy management approach remains relatively basic and does not fully utilize modern smart building technologies. Therefore, a comprehensive energy efficiency program is proposed to improve operational efficiency, reduce energy consumption, and support long-term sustainability. The first proposed is to implementation of a smart energy monitoring system. The system allows real-time monitoring of electricity consumption, detects abnormal energy usage, and support better planning and maintenance decision making. Secondly, a solar photovoltaic or solar PV system is proposed. So rooftop solar panels can generate renewable energy for common areas facility, reducing electricity bills, lowering carbon emissions, and providing long-term operational savings. The third proposal is a smart lighting system equipped with motion sensors, daylight sensors, and automated dimming controls. This will reduce energy wastage, improve lighting efficiency, and lower maintenance costs. Another important initiative is the smart water management system, which uses IoT-based sensors to monitor water consumption and automatically detect leaks. This helps reduce water wastage and utility costs while improving maintenance efficiency. Finally, smart lift energy management is proposed through lift modernization and regenerative drive technology. This technology can convert braking energy into reusable electricity, improving lift efficiency and reducing overall energy consumption. Together, this initiative will transform Pangsapuri Damai 25 into a more sustainable, efficient, and technology-driven residential development. For the first image, these figures illustrates the existing energy-saving measures currently implemented between Pangsapuri Damai 25 and the proposed improvement for future enhancement. The first initiative focuses on LED lighting. While LED lights are already installed in the selected common areas, the proposal recommends replacing all remaining conventional lighting with smart networked LED lighting systems. The second initiative involves motion sensor lighting. Currently, motion sensors are installed only in selected locations. The proposal suggests expand the sensors coverage throughout all common areas to achieve greater automation and energy saving. The third initiative focuses on a timer control lighting. Instead of operating as a standalone system, these lighting controls can be integrated into a centralized smart building management system for more efficient control and monitoring. The fourth initiative relates to FRID access system. Currently used for resident access control, the system can be integrated with occupancy-based energy management system to optimize the energy usage based on the actual building occupancy. Lastly, the CCTV system can be upgraded with energy efficient surveillance equipment and intelligent recording modes to reduce unnecessary energy consumption while maintaining security performance. Overall, this figure demonstrates how existing building system can be upgraded and integrated into a smarter and more efficient energy efficient building environment. For the second image, which is the revenue generating and efficiency initiative proposal, this figure presents the proposed smart technologies that support both energy efficiency and operational performance improvement within the building. The first technology is the smart energy meter, which enables comprehensive real-time electricity monitoring. This allows management to track energy usage pattern and identify opportunities for energy savings. The second technology is the IoT water sensors. These sensors continuously monitor plumbing systems and detect leakage at the early age, reducing water loss and preventing costly repairs. The third initiative is the smart lighting systems, which automatically adjust the lighting based on the occupancy and environmental conditions. helping to minimize the electricity consumption. The fourth initiative is the solar PV system, which generates renewable energy and from solar panel and reduces the dependency on grid electricity. The fifth technology is the lift monitoring, which continuously monitor lift performance and identify potential faults before major breakdowns occur. The sixth initiative is the Building Management System or BMS, which serves as a central platform integrating building operations, maintenance monitoring, and energy management. Lastly, occupancy sensors are proposed to monitor building usage patterns and optimize energy consumption based on actual occupancy levels. Together, these smart technologies improve efficiency, reduce operational costs, and enhance the sustainability performance. Moving on to the proposed future smart building concept. To further improve sustainability and operational efficiencies, it is proposed that Pansapuri Damai 25 gradually adopts the Building Management System or BMS. The BMS will function as a centralized platform that integrates multiple building systems, including the energy monitoring system, lift monitoring, water consumption monitoring, security system, maintenance scheduling, and resident complaint management, with all buildings information integrated into a single system. Management can monitor building performance in real time and receive automatic reports on system conditions and maintenance requirements. This approach enables faster maintenance responses, improves decision making, reduces operational inefficiencies, and lower long-term maintenance costs. The integration of these smart technologies is expected to transform Pangsapuri Damai 25 into a conventional residence development into a smart and sustainable building. Expected benefits include reduce energy consumption, lower operational costs, improve the maintenance efficiency, enhance building performance, increase resident satisfaction, and stronger long-term sustainability. Overall, the proposed smart building concept align with the objective of creating future-ready residential development that provides better living conditions for residential while supporting efficient building management. Moving on to the image, this figure highlights the expected outcomes that can be achieved through the implementation of the proposed smart technologies and energy efficiency program. Firstly, electricity consumption is expected to decrease by approximately about 20 to 30% through the use of smart energy monitoring systems, intelligent lighting controls, and solar energy generations. Secondly, water consumption can be reduced by approximately 15 to 20% through IoT-based water monitoring system and early leak detection technologies. The figures also shows that maintenance costs can be reduced through predictive maintenance practices where potential issues are identified and addressed before major failure occur. Another key benefit is the extension of equipment lifespan. A continuous monitoring allows building system and equipment to operate more efficiently and experience less wear and tear, resulting in fewer breakdowns and longer service life. From the resident's perspective, improved maintenance performance and service quality will increase comfort, convenience, and overall satisfaction. Finally, environmental performance will improve through reduced energy consumption and lower carbon emissions, supporting the building sustainability objective. Therefore, this figure demonstrates how smart building technologies not only improve operational efficiency but also create long-term financial, environmental, and social benefits for both management and the resident.
Assalamualaikum, I'm Shahada binti Hassan and I'm going to present 7.0 Enhancement Strategies and Smart Solutions. So for these sections, we'll present the enhancement strategies and smart solutions for Pansapuri Damai 25 based on the building inspection and maintenance audit. The audit was identify several key design-related issues that are affecting the building overall conditions and maintenance efficiency. And firstly, there is a requiring water leakage problems, which is suggest issues with waterproofing system and may lead to further damage if not properly addressed. Secondly, the building has concealed piping system which are difficult to access and make repair and maintenance for work more time consuming and costly. And thirdly, construction cracks are have been observed, indicating possible material deteriorations or structural stress that is require monitoring. In addition, the building is experienced with issues with aging lift system, which may affect safety, reliability, and user comfort. And lastly, there is a poor maintenance accessibility, which limits efficient inspections and slow down repair work. So overall, these issues highlight needs to be improved design planning and smart maintenance solutions to enhance safety, efficiency, and long-term building performance. We're moving on to 7.1, which is Proposed Maintainability Enhancement Program. We're focusing on the first one is smart waterproofing systems. This is proposed to address frequent leakage issues caused by the aging waterproofing material. The improvement includes using a high durability polyurethane waterproofing membranes, installing waterproofing monitor sensors, applying thermal imaging for early leak detection, and implementing a scheduled waterproofing replacement programs. The expected benefits are reduced leakage complaints, lower repairs and maintenance costs, and improved long-term durability of the building. And the second solution is the accessibility building service design. This addresses the issue of concealed piping systems that are difficult to access during maintenance. Proposed improvement including installing removable access panel, constructing dedicated maintenance shafts, creating service corridor for utilities, and using modular piping systems. The expected benefit include faster maintenance and repair rates, reduced labor and hacking costs, and less damage during servicing. The third solution is the structural health monitoring system. This is introduced to address issues related to structural cracks and possible settlement concerns. The system includes cracks movement sensor, settlement monitoring devices, and real-time structural monitoring dashboard, and regular engineering assessment. The expected benefit of the systems are early detection of defects, improving building safety, and reducing costs for major structural repairs. The fourth solution is smart lift modernization. This is proposed to overcome frequent lift breakdowns and aging lift system in the building. The improvements include smart lift monitoring sensors, regenerative drive technology, flood-resistant lift components, and predictive maintenance software. The expected benefits are reduced downtime, lower maintenance costs, and improved resident satisfaction. The fifth proposed solution is maintenance-friendly building material. This addresses the issue of high maintenance demand caused by the aging material within the building. The purpose improvement includes the use of durable low-maintenance materials for future upgrades, applying moisture corrosions and wear-resistant finishes, and standardizing replacement components to simplify maintenance work. These improvements are expected to reduce maintenance frequency, extend the lifespan of the building components, and lower overall life cycle costs. By upgrading the more resilient materials, the building can reduce recurring defects and improve long-term performance with less maintenance interaction. These sections focus on improvement of maintenance practice. The main objective of this improvement is to reduce recurring building defect, improve maintenance response time, and increase operational efficiency and support long-term building sustainability. Although the current maintenance system is still functioning inadequately, several requiring issues have been identified, including water leakage, lift breakdowns, manpower shortage, and delay response times. So these issues indicate the need for a more proactive and technology-driven maintenance approach. The image shown illustrates the concept of maintenance modernization initiative, where the traditional reactive maintenance is enhanced with digital tools better than planning system and improved coordination. By adopting these improvements, the building manager can shift forward a more efficient maintenance system that minimize breakdowns, improve service delivery, and ensure better overall building performance. Continuing the improvement of maintenance practice, the first strategy is the implementation of predictive maintenance. Currently, the maintenance at Pasampuri Damai 25 is mainly preventive and corrective in nature, which means issues are often addressed after they occur. To improve this, the proposed actions includes installing lots monitoring sensors, continuously tracking equipment performance, setting up automated maintenance alert, and scheduling repairs before failure occurs. The expected benefit of this approach are reduced equipment failures, lower maintenance costs, and improved system reliability. The second strategy is the implementation of computerized maintenance management system or CMMS. This system is proposed to digitalize maintenance operation by introducing a digital work order system, asset maintenance history trackings, automated maintenance scheduling, cost tracking and reporting, and also contractors' performance monitoring. The expected benefit includes faster response time, better maintenance planning, and improved record management. So overall, this strategy shift forward to a more intelligent, data-driven, and efficiency maintenance system. Continuing with the improvement of maintenance practice, the third strategy is the root cause analysis program. So this approach addresses the issue of repeated building defects that are often fixed without solving the underlying causes. The purpose actions include conducting detailed defect investigation, analyzing requiring issues through trend analysis, identifying maintenance patterns, and implementing permanent repair solutions instead of temporary fixes. The expected benefit of this program includes a reduction in requiring defects, lower long-term repair costs, and improve overall building performance. The fourth strategy is the maintenance workforce enhancement. This is introduced due to limitation of the current manpower, which is insufficient for the scale of the building. The proposed improvements include increasing additional manpower and strengthening the technical maintenance team. The expected benefit are faster response times, better inspection coverage, and improved monitoring of building system. So we move on to 7.3, which is the financial planning and budget enhancement for Pansapuri Damai 25. The key issues identified include insufficient maintenance fee collection, which lead to delayed maintenance work and limited repair funding. In addition, the increasing age of the building has created higher financial pressure for long-term maintenance requirements. To address these issues, a structured long-term maintenance financial plan is proposed. This includes establishing an annual maintenance budget, setting up an emergency repair fund, and creating a sinking fund for major asset replacement. In terms of budget prioritization, a risk-based approach is recommended. High priority allocations are focused on the structural repairs, lift systems, plumbing and water systems, and fire safety systems. Meanwhile, medium and low priority items include routine maintenance, cosmetic works, and non-critical upgrades. Several financial improvements are also provided, such as strengthening the sinking fund, improving the fee collection system through the digital payment and reminders, implementing a CMMS for financial tracking, introducing cost-saving measures like energy efficient systems and generating additional income through EV charging stations. Overall, the strategy aims to ensure the sustainable maintenance funding, better cost control, and long-term preservation preservation of the building value. Moving on to 7.4, which is integrations of smart technologies through lots and automations to improve the building management at Pansapuri Damai 25. The system is the first system is the lot-based building management system or BMS. These provide a centralized real-time monitoring platform that tracks key building systems, including lifts, pumps, electrical systems, water tanks, fire systems, and lighting systems. The main benefit of these systems include early fault detection, reduced downtime, and faster maintenance response, allowing issues to be identified and resolved more efficiently. The second system is the Smart Water Leakage Detection System. This system is installed at high-risk areas such as rooftops, water tanks, plumbing risers, and common areas to detect leakage at an early stage. The benefit including immediate leakage alerts, prevention of major water damage, and lower repair costs. Overall, the integration of lots and automation technologies allows the building to move forward a smarter, more proactive maintenance system that provides the improved efficiency, safety, and long-term sustainability. Continuing with the integration of the smart technologies, the third system is the smart lift monitoring system. So this system involves installing sensors such as vibration sensors, temperature sensors, and performance monitoring devices within lift system. So these sensors allow lift performances conditions, enabling early detection of potential faults. The main benefit includes predictive maintenance, fewer unexpected breakdowns, and improved lift reliability for users. The fourth system is the computerized maintenance management system or CMMS. These systems serve a centralized digital platform for managing maintenance activities, including work orders, asset records, maintenance schedule, and contractor tracking. The benefit of this system includes better coordination among maintenance teams, faster response time to issue, and improved cost and maintenance control. This section is focused on energy efficiency enhancement strategies aimed to improving sustainability and reducing operational costs at Pansapuri Dhamma 25. Their energy efficiency plays an important role in supporting lower operational costs, improving environmental sustainability, and enhancing long-term building performance. Currently, several initiatives are already in place, such as LED lighting, climate control lighting system, motion sensor systems, and RFID access control. However, the system is still relatively basic and lack of advanced smart monitoring and optimization features. So the further improvement, the further improve this, um, the first strategy is LED lighting, as mentioned. This involves replacing all conventional lighting with LED systems and extending coverage to all key areas, including corridors, staircase, parking areas, and utility rooms. Two aspect benefit including lower electricity consumption, longer system lifespan, and reduced maintenance costs. The second initiative is the Smart Lighting Control Expansion. This strategy focuses on expanding motion sensors and timer-based lighting system to additional areas within the building, including staircase, parking zone, storerooms, and service corridors. The main benefit of these systems are reduced unnecessary electricity consumption and improve overall energy efficiency by ensuring lightings are only used when needed. The third initiative system. This involves installing lots with smart meters to monitor key systems such as lifts, pumps, lighting systems, and water tanks. The benefit of this system includes real-time energy tracking, early detection of abnormal energy usage, and better cost control for the building management. Continuing for the fourth initiative is the lift energy efficiency upgrade. The strategy focuses on modernizing the lift system by installing energy efficient motors, upgrade controllers, and improve lighting system inside the lift cabins. The expected benefit includes lower electricity consumption and reduced breakdown occurrences, which will improve overall system reliability and user experience. The fifth final initiative is the solar PV system as the future strategy. These involve installing solar panels or reducing dependency on the conventional electricity supply. The key include the long-term cost saving, the use of renewable energy, and overall sustainability improvement for the building. So in conclusion, the study on Pasapuri Dharma 25 highlights that the building is facing several interconnect maintenance challenges, includes water leakage, aging systems, structural concerns, and limited maintenance efficiency. So these issues are not isolated but are mainly driven by directive maintenance practice, aging infrastructure, and insufficient integration of modern technologies and financial planning. Therefore, a shift toward a more proactive and smart maintenance approach is essential. These include the adoption of predictive maintenance, lot-based monitoring system, CMMS integration, and improved financial planning and energy efficient solutions. So by the implementing these strategies, the building management can move from a reactive fix when it's failed to approach the more preventive and data-driven system. Ultimately, this will lead to improved safety, reduced long-term costs, better operational efficiency, and enhanced quality of life for residents. That's all from us. Thank you.